Hey guys, welcome to my channel. Today I'm going to be talking about gravitational potential energy. First of all, its symbol is EGH and its unit is joules. When it comes to its definition, it contains three parts: energy, the ability to do work; potential, the gained energy that is stored in the object; and gravitational, which means the object must be placed at a height above or below zero height, which is the Earth level. For example, when you jump up, your energy transfers into gravitational potential energy because your position is upper. In industry field, EGH is used in construction, wrecking ball. Let's see. Wrecking ball transmits EGH stored in it into kinetic energy, which hits the wall or building with huge energy. Similarly, when a ball is dropped, its EGH gained due to its height gradually transfers into kinetic energy. What's different this time is that the ball bounces up again. Its kinetic energy transfers into potential energy again. So what are the factors that determine this gravitational potential energy? What does it depend on? And how should we calculate it? Here are two balls of different masses that are going to be dropped into two little bowls of millets. In order to describe the value of energy visually, I used two bowls of millets. By observing the depth of the ball dropped into the millets, we can actually see how large it is visually. Since EGH is stored in the object, it's hard to measure its value. But in this free fall case, if air resistance is negligible, then the gravitational potential energy at the top when dropping the ball is fully transferred into kinetic energy. So we can observe the kinetic energy in order to see how large the potential energy is. So my hypothesis is both the height and mass of the object will affect its value. The heavier it is, the greater its EGH is, and the higher the object is positioned, the greater potential energy it carries. So first part, possible results. The ball with greater mass will hit with more energy. Let's see the lab. Let's give a shot to the millets. What if without the two balls? Conclusion: the heavier the ball is, the greater gravitational potential energy it carries. What about height? Here I have two balls of the same mass, but they will be released at different height. Height 1, when the pink ball is released, is 2 times higher than the blue ball. Let's begin. Let's give a shot to the millets. Without a ball. Conclusion: EGH is affected by two factors, mass and height. Now, let's have a look at its formula. EGH is equal m times 3 times h. Alright, let's have a look at its derivation. W is equal to F times delta D. This is the formula we have already learned for work. F, basically, in this case, is just gravity. Because, as we said earlier, this is about EGH, and it is highly associated with mass and gravity. M times G times delta D, because F is just gravity, gravity is equal to M times G, and delta D is just delta H in this case. Mass and height are two factors that affect our EGH value according to our previous explanation. M times 3 times delta D is equal to M times 3 times delta H, which is just the formula we are trying to solve. Okay, second method. We know how the EK is equal to mv2 squared divided by 2. This is the formula we already know for kinetic energy. Even if you don't know, it's okay, I'll show you. W is equal to F times delta D, and in this case, F is just F net times delta D. F net is A times M and times delta D. This is the formula we learned in the fourth unit. Yeah, A times M. And then another formula we have learned is 2A delta D is equal to V2 squared minus V1 squared. Delta D is equal to V2 squared minus V1 squared divided by 2A. But we all know V1 in this case is equal to 0. When the ball is dropped, it doesn't have any velocity. So V1 is equal to 0, then delta D is V2 squared divided by 2A. And if we substitute it into the original formula, then it would be W is equal to A times M times V2 squared divided by 2A. And across out A, we will have mv2 squared divided by 2, which is the formula for kinetic energy that we wanted to solve for. And then now, in order to get our goal, which is the formula for EGH, we need to substitute another thing. So the same formula, V2 squared is equal to V1 squared plus 2A delta D. We can isolate V2 squared in this case. V2 squared is equal to 2A delta D because V1 is equal to 0, and V2 squared is equal to 2A delta H because delta D is just delta H here because we want the height instead of the length. And if we substitute this into the formula for kinetic energy, then we'll get W is equal to M times 2A delta H divided by 2. 2 is crossed out, and then we'll get MA delta H. And in this case, A is just G, which is acceleration due to gravity. Then we get mg delta H. It's the formula we were solving for. Alright, let's have a look at the question. A wrecking ball with a mass of 315 kilograms hangs from a crane on a 10 meter of the cable. If the crane swings the wrecking ball so that the angle that the cable makes with the vertical is 30 degrees, what is the potential energy of the wrecking ball in relation to its lowest position? So it's looking for EGH. And here's the ball, and it is supported by a cable, and the cable makes an angle of 30 degrees to the vertical. So here is where the ball is at the lowest position. So this is the lowest position, and it forms a triangle position. And then EGH is equal to M times 3 times delta H, and we know M is 315 kilograms and G is 9.81 meter per second squared and times H. So we need to solve for H. The H is in relation to its lowest position, which means from the lowest position to the highest position, which is right here. So we are solving for this, which is H. And we can actually, this whole thing is equal to this, which is 10 meters. So here, this part is equal to 10 minus H. We can solve this easily by using trigonometric. So 10 minus H is equal to cos 30 times 10. H is, in this case, equal to 10 minus 10 times cos 30. So it is equal to 1.3397 meter. So EGH is equal to 315 times 9.81 times 1.3397, and it's equal to 4140 joules. Here's the answer we want to solve. Well, so that's it. I hope this helps. Thank you, and bye!